Dear students, in our today's video, we are going to learn about atomic radius. Atomic radius is one of the most fundamental properties of atom. Atoms are actually unique. One atom is different from another atom, and these are different from each other due to having different properties. Atomic number, for example, is one of the most fundamental properties of an atom, that is, the number of protons in the nucleus or the number of electrons in the outer region of atom. And atomic mass is another fundamental property of an atom, that means the number of proton and neutron present in the nucleus of a certain atom. Atomic radius, on the other hand, is the atomic size of an atom. It determines how big an atom is. Atomic radii is the plural of atomic radius. Atomic radii means when many atoms are involved. Atomic radius is defined as the average distance between nucleus and the outermost electron. It is average distance between nucleus and the outermost electron. As atomic radius is the distance between the nucleus and the outermost electron, it is measured in the units of length, and because the atom is very small, and so will be the case of atomic radius, we prefer to use the very smaller units of length, such as angstrom in most of the cases, and sometimes we use picometer, and some other times we are also allowed to use the concept of nanometer. Angstrom, which is the most frequently used unit of atomic radius, is actually related to a certain length. Angstrom, which is expressed as A, is equal to 10 power minus 10 meter. It is important to note here that atomic radius cannot be directly measured, because atoms are very tiny and it is not possible for someone to have a direct analysis of an atom. Atomic radius is actually determined from the bond lengths of different homonuclear atoms. For example, hydrogen bonded to hydrogen, so we'll have a certain bond length, and half of that bond length will be treated as the atomic radius of one atom of hydrogen. Similarly, carbon bonded to carbon, carbon bonded to carbon, this is called as bond length. This is bond length of two carbon atoms, and this bond length is 1.54 angstrom. So the radius of carbon will be half of this, because we know that bond is formed by the overlap of orbitals of two carbon atoms. So the atomic radius of one carbon atom will definitely be the half of bond length between the two carbon atoms. So the atomic radius of carbon must be 0.77 angstrom. Similarly, sulfur bonded to sulfur will have the bond length of this is the bond length of 2 sulfur, this is bond length, and it is equal to 2.06 angstrom. And the atomic radius of sulfur atom will definitely be this is the value of atomic radius of carbon, and atomic radius of sulfur will be the half of this value, which is 1.03 angstrom. And it is the atomic radius. It is the atomic radius of sulfur. So it is important to Recall that atomic radius is the distance between nucleus and the outermost electron, and this is always measured by measuring the bond lengths. It is the half of the bond length between two similar atoms. And we have in the periodic table the already determined values of many atoms, and here we must also focus on another important point, and this is that atomic radius has the trained in periodic table. Trained is very important to understand because atomic radius is a fundamental property of atom upon which many other properties depend. We will discuss it in our coming videos, that ionization potential and electron affinities and electronegativities, and sometimes melting boiling points are dependent on the atomic radii. So therefore, to have a keen understanding of atomic radius is a very important point to understand other properties of elements and the compounds they form. The trend in atomic radius is very regular and straightforward. Atomic radius decreases across the period when we move in the horizontal rows. Atomic radius decreases across the period, which means that lithium, the size of lithium will be the biggest in its respective period. Then beryllium is somewhat smaller than lithium. Then boron, carbon is even smaller than nitrogen, oxygen, and fluorine. And here, in the case of noble gases, there is the reversal of trend somewhat. They are always bigger than the preceding halogens. Noble gases are bigger in size because the completion of shell takes place here. But in the preceding members, there is a regular trend. Lithium to fluorine, atomic radius gradually decreases. It is because atomic radii are actually directly proportional to nuclear charge. So from lithium to fluorine, actually the dominant character which is defining the atomic radii values is nuclear charge. It is increasing, which is creating greater nuclear force, which is responsible for attracting electron cloud towards itself. Therefore, atomic radii decrease gradually and regularly up to fluorine. Similar is the case of every period. In each period, this is the same case, such as in the downward from sodium to argon, atomic radii decreases, and up to chlorine. Again, argon is slightly bigger in size than chlorine. In case of groups, when we move downward in each group, atomic radii increases. Atomic radii increases because of the increase of shells. So sodium is quite bigger than potassium, rubidium, cesium, and francium. So this is the decrease across the period, decrease in atomic radii, and downward in each group there is the increase in atomic radii. And similar is the case of overall periodic table. This understanding of atomic radii enables us to predict the atomic radii of different atoms. Comparison is very important. Somewhat we are asked about the comparison. For example, potassium and carbon and nitrogen and beryllium are given. Potassium, nitrogen, carbon, and beryllium are given, and we have been asked to determine the smallest atomic radii. So if we know about this trend, we'll be quick in telling that the nitrogen will have the smallest atomic radii, because downward atomic radius is increasing, and across the period it is decreasing. So nitrogen lies at the rightmost position in the first period, so it must have the smallest atomic radius. In our coming video, we will discuss about ionization potential and electron affinity. These are very important properties of atoms upon which depends the chemical bonding, and these two properties and electronegativity as well depend on atomic radius values. For many more videos about various important concepts of chemistry, stay in touch with us, and thank you for watching.